All right, today we're going to look at some problems from section 8.3. Specifically, we're focusing on geometric sequences. Later on in another video, we'll do the geometric series. And let's recall that our equation for a geometric sequence, a sub n equals a1, which is the first term, times r, our common ratio, raised to the n minus 1. So as long as we're multiplying by the same number each time to get the next number in the sequence, then we have a geometric sequence. If not, then we do not. So here I look and I see 64, 32, 16, 8, and I notice that I'm multiplying by 1/2 each time. So yes, we have a geometric sequence. So a sub n equals 64, our first term, times the common ratio, 1/2 raised to the n minus 1. Here, what I notice is that we're actually subtracting 22 each time. So no, because there's no common ratio. It doesn't matter that this one actually is an arithmetic. We don't need to indicate that as long as we know it's not geometric. Although, just as a quick review, I will do the geometric or arithmetic rather sequence formula. So again, we have our first term minus, because we're subtracting 22 because that's our d, and minus 1. So again, just as a review, I put down the arithmetic formula. All right, here may not be as obvious as we start. As we go from 1/4 to 1/2 to 1 to 2. But what I see is if I multiply the 1/4 by 2, I get 2/4 or 1/2. If I multiply 1/2 by 2, I get 1, and so on. So yes, and our common ratio is 2. So a sub n, our first term, common ratio raised to the n minus 1. All right, a couple other problems here. Here we're given different pieces of information and asked to write the nth term. So again, we're writing the rule. And I'll put that up here again. an equals a1, our first term, times the common ratio raised to the n minus 1. All right. So notice here I'm given the third term, a sub 3, which is 9, and the common ratio. So I know a sub n equals a1 times our ratio raised to the n minus 1. And I need to solve for a1. So I need a value for a sub n and n, and that's where this information comes in. This tells me that the third term is 9. So 9 equals a1 times our ratio. I'm going to plug in 3 minus 1. So that's 2. 3 squared is 9. The first term is 1. 1 times the common ratio raised to the n minus 1. All right, so I'm going to just jump into it here. Fourth term is 5. So I know 5 equals the first term times the common ratio raised to the n minus 1. So 5 equals the first term, that's 3. 1/2 cubed is 1/8. And when I multiply both sides by 8, our first term is 40. So our rule will be 40 times 1/2 raised to the n minus 1. Okay, now look here, we're given 2 terms in the sequence. And this is actually a typo. This should be 28, not 128. All right, so we've got 2 of these types of problems. I'm going to do them 2 different ways. So for this, similar to what we did here, we could write 1792 equals the first term times, now we don't have the common ratio, r raised to the 5 minus 1, so that's r to the 4th. And then I can also, using this information, 28 equals the first term times r, and then n minus 1, 2 minus 1 is 1. So I know here that r, if I solve this one for r equals 28 over a sub 1, right? I divided both sides by a sub 1. And I could substitute that here. Although now I am raising the 28 to the fourth and the A1 to the fourth. So we can do it that way. I think it gets a little more complicated than what we would want. So let's see, is there a better way using our two equations? Again, well, what if I solve them both for a sub 1, or even solve this one just for a sub 1? So let's divide by r. So a1 equals 28 over r. Now I can substitute that here. So 1792 equals 28 over r times r to the fourth. We'll have an r to the fourth divided by an r. So that's 28r cubed. Divide both sides by the 28. So again, we're going to use our calculators. So 1792 divided by 28 is 64. Take the cube root. And we see our common ratio is 4. We still need to solve for a1, so I'm going to go back. 28 equals a1 times 4. a1 is 7, so our formula is 7 times 4 to the n minus 1. All right, this one I'm going to do a little bit differently. So we have our a2 term and our a sub 6, or our 6 term. So here's what I know is in between. I have a3, a4, and a5. So how do I get from a2 to a6? Well, I'm going to multiply by r to get a3. I'm going to multiply by r to get a4. I'm going to multiply that a4 by r to get a5, and then I'm going to multiply by another r to get a6. So see, I have 6 minus 2 is 4. So I'm going to multiply the second term by r 4 times to get the sixth term. So I can rewrite this as an equation as negative 72 r to the fourth, right? R times r times r to r is r to the fourth equals negative 1 over 18. So I'm going to multiply both sides by negative 1 over 72. So I have 18 times 72. I wrote 79 over there. Let me correct that. And we get now a positive 1296. And here comes our big topic for the year, right? We're taking an even root of an even power. So remember, that gives us the absolute value of r. And I want to raise that 1296 to the fourth. So when I hit the caret button, it brings back the previous answer. Raise it to the 1/4. I get 6. So r is plus or minus 6. So as it turns out, there's actually two different equations, two different formulas that would take us from this second term to this fourth term. So I need to still find the first term. So a1, or a sub n rather, equals a1 times, I'll use 6. I'll plug in negative 72 and 2. And so 72 divided by 6 is 12. So the first term here is negative 12. So if my r is 6, so one formula is negative 12 times 6 to the n minus 1. And I know I'm running out of a little bit of room here. So what if I have negative 6's in r? So negative 72 equals a1 times negative 6 to the 2 minus 1. Well, 2 minus 1 is 1. Again, if we divide now by negative 6, we're going to get positive 12. So the other equation is positive 12 times negative 6 to the n minus 1. So one of the things is pattern recognition. So what was different here than here? Like, why did we end up with two options and only one here? Well, one of the keys is, notice that this was an odd number away. So when we ended up taking an odd root of an odd power, we only end up with the r. But here we are an even number away. We took an even root of an even power. That's when we get absolute value. So that concept that we talked about that we would see over and over and over again back in August and September, here we are in chapter 8, and we're still seeing that topic come up. So hopefully that helps, and we'll see you soon.